Good morning, Pennsylvania. I'm Cole Hartfax from TSA News.
And I'm Olive Update.
Today's headline takes us back in time to one of Earth's driest regions.
The green past of the Sahara-Arabian Desert cave deposits reveal recurring humid periods over 8 million years. If you thought that this desert was always dry, this story is about to rain on that assumption.
A new study conducted by the Max Planck Institute for Chemistry reveals that the Sahara-Arabian Desert wasn't always an inhospitable biographical barrier and once had abundant monsoon rains.
By studying several caves across Saudi Arabia, scientists discovered evidence of repeated wet periods over 8 million years caused by monsoonal rainfalls from cave deposits known as speleothems, or more commonly recognized as stalagmites and stalactites.
These humid periods lasted thousands of years, bringing vegetation and freshwater, an ideal environment for early humans, ancestors, and animals, which they took advantage of.
To help us break it all down, let's hear from one of our researchers on the project.
Joining us now is climate scientist Rainer Schein. Rainer, thank you for being here.
It's my pleasure. Hello, I'm Rainer Schein, and I'm speaking from the Max Planck Institute in Mainz, where our research centers on understanding how the landscapes we see today were formed by past climates.
That's fascinating, Rainer. Now, how did we find out about past climates from cave deposits?
Well, speleothems form when rainwater seeps into a cave and dissolves calcium carbonate from limestone rocks. This calcium carbonate is later crystallized, being preserved drip by drip. We can study these speleothem isotopes using radiometric dating techniques and can figure out when wet periods occurred and even predict their intensity.
So, these caves are essentially like time capsules?
Right on, they're one of the most reliable climate archives we have, showing that the monsoon rainfalls return repeatedly over millions of years.
What does this tell us about the history of the Sahara-Arabian region?
It informs us that the region flipped between extreme dryness to a wetter, greener environment. During the humid periods, the region would have seen grasslands, rivers, and lakes, greatly affecting the migration of human and animals.
What does history possibly support?
Like expert Faisal Al-Jabrin has pointed out, getting an understanding from these periods is essential to explaining both mammalian and early joining migration between Africa and Eurasia. Thank you, Rainer Schein, for shedding some light on this humid history.
The study also entailed that these wet periods came to end and due to long-term cooling in the northern hemisphere, which caused global rain belts to shift southwards and weaken the monsoon cycle.
Understanding these historic changes can help scientists predict how modern climate change may affect rainfall patterns in desert regions.
This is Cole Hartfax.
And I'm Olive Update.
Thank you for tuning in to TSA News.